It is time for section 14.3, ellipses. All right, in your book, if you can turn to page 627, this chart is great. You are definitely going to want to copy down this chart into your notes. Super informative. One thing I want to point out, this chart is only for ellipses that are centered at the origin, which means that are centered at 0, 0. For our lesson today and on ellipses this year, we are only going to focus on ellipses centered at 0, 0. Now, in actuality, ellipses can be shifted right, left, up, down. The center does not have to be at 0, 0. But again, that's what we're going to focus on today. In pre-calc, we're going to go ahead and shift ellipses all over the place. But for trig, we're doing it centered at 0, 0. All right, now that we got that straight, when I say an ellipse, what am I talking about? This section 14.3 ellipses. Well, when you were little, you called them ovals. Now we're going to call them ellipses. The formal definition of an ellipse from page 627. An ellipse is the set of points in a plane such that the sum of each point's distance from two fixed points, the foci, is constant. All right, so we're going to talk about these foci in a minute. It's kind of when I picture an ellipse, it's almost like I picture it from these foci, like a rubber band, stretching it out around it and forming this oval, either a horizontal or a vertical oval. All right, but let's get some information about an ellipse. I really want to get some major vocab down, and this is all in your chart, but I'm going to draw it also on the whiteboard so we can follow along. All right, for our first sketch, I have sketched a horizontal ellipse for you. The center is at 0, 0, just like we talked about. The center is going to be at 0, 0 for these purposes. All right, the longer part of the ellipse, this really long axis here, this is going to be called the major axis. So this is the major axis from here to here. Now, the major axis has a vertex here and a vertex here. So again, the vertices, we're going to just label them with V's, are located on the major axis. Now, the distance from the center to a vertice is a distance of A. Again, from a center to a vertice is a distance of A, which means the full length of the major axis is 2A. Major axis. Okay, next thing, now we have the shorter axis. The shorter axis is called the minor axis. Glad they use names that are so easy to remember. The minor axis, now just like the major axis has vertices, the minor axis has these points called co-vertices. So I'll just label them CV and CV. So we have our minor axis with the co-vertices, and again, very friendly notation, the distance from the center to a co-vertice is B. Again, center to a co-vertice, B. So that means that the length of the minor axis must be 2B. All right, now what about these foci we were talking about? The foci always lie on the major axis. So I'm going to put a foci point here, a foci point here. Let me get rid of these A's for a second because I don't want this to become confusing. So we have a foci point here, foci point here. So in other words, this is a focus, this is a focus. The plural form is foci. All right, the distance from the center to a focus point is C. So this is C, this distance from the center to a focus, and center to a focus. But we already talked about how the distance from the center to the vertice was A. And the center to the vertice, make it all the way to the vertice there, is A. All right, so a lot of important vocabulary happening here. All right, let's take a quick look at a vertical ellipse. It's going to be very similar. All right, taking a look at our vertical ellipse. Again, the center's right here, and that is 0, 0 for our purposes. The major axis is now located on the vertical axis, or the y-axis. This major axis, again, has a vertex and another vertex. So the major axis always has those vertices. The distance from the center to the vertex is, again, A. Center to the vertex is A. This is the minor axis here along the horizontal. So it has a co-vertice point right here, another co-vertice point right there. The distance from the center to a co-vertice is B. Distance center to co-vertice B. And then, of course, we can add in our two foci points. So foci point and a foci point. A focus will always be on the major axis. So if it opens vertically, it's going to be here. If it opens horizontally, it would have been going the other way. And again, the distance from the center to this focus point is C, but the distance from the center all the way up to the vertex is A, like we said. So the distance from the center to the focus is C. We'll draw it over here. Center to the vertex is A. All right, so far so good. Okay, I'm just going to point out an obvious fact here. The major axis is always the longer axis, right, compared to the minor axis. So of course the major axis is always longer than the minor axis, which means that A is always greater than B. This isn't true with all the conic sections, as we're going to find out later, but once we get to hyperbolas. But in terms of ellipses, A is always greater than B. Again, just for ellipses, I want to just kind of put this off to the side so you don't... Okay. That being said, since A is always bigger, that's going to help us recognize which equation to look at. So let's take a look in our chart here. Notice this is a horizontal or a wide ellipse. Look at where the A is located. This A squared is located under the X squared. So the A, or the larger value, is near the X, and the ellipse opens large along the X axis. All right, now look at this tall vertical one. This vertical ellipse opens along the Y axis, and notice that A squared is now under the Y squared. Very important to notice that. So I just want you to kind of think of it as if the big number is under X squared, it's horizontal. If the big number is under Y squared, it's vertical. All right, let's just look at that again in terms of for our notes purposes. So if we have a wide or a horizontal ellipse, that big number will be under the X squared. And if we have a tall or a vertical ellipse, that big number will be under the Y squared. So wide, the big number with X squared, tall, the big number with Y squared. All right, moving on. All right, your eyes do not deceive you here. I have written down that A squared minus B squared equals C squared. Very confusing. This goes against Pythagorean theorem. Doesn't really make sense. However, this is the equation you are going to use when you're trying to find C squared in an ellipse. So it's going to be really easy to grab that A squared value and that B squared value right from the equation, as we'll see in a second. But when you want to solve for C squared, you're using this equation. I'm trying to make a big deal about it because I want you to remember, keep in mind, it is an ellipse. It is not a right triangle. So we're going to use A squared minus B squared equals C squared. As crazy as that sounds, there's a big explanation for that. I'm not going to go into it right now. If you do look at the top of page 628 in your book, you can kind of see the justification for this. It's really not too much. If you want to check it out, you can. But for our purposes, no, you need to use this. All right, we're going to do two examples together. So let's take a look at example one. All right, our first example wants us to graph 9x squared plus 16y squared equals 144. All right, I went ahead and grabbed our two equations from our great box of information. And I have the equation for a horizontal and the equation for a vertical. One thing I'm noticing is that they both equal 1 and my equation equals 144. So I really need there to be a 1 on the right-hand side. So my very first step is to divide by 144 on both sides. That means I have to divide each term by 144. 9 over 144 is going to actually simplify to 1 over 16. So I can just write that as x squared over 16 plus 16 over 144. That'll simplify to 1/9. So that's 1 y squared over 9 equals 1. All right, now it's looking like an ellipse. Now remember, we made a big deal about this. The A value, or the A squared actually in this case, I should say. The A squared value is always the bigger value. It's hanging out with the X here, which means in this case, I have a horizontal or a wide ellipse. I'm going to just do a little sketch off to the side. That also means that A squared equals 16. It also means that B squared equals 9. Now, I said that we were going to use that strange equation, A squared minus B squared equals C squared, which means 16 minus 9 equals C squared. So 7 equals C squared. Okay, now when I was going over the picture before, I was saying the distance from the center to a vertex, A. Distance from a center to a co-vertice, B. Distance from the center to a focus, C. I didn't say anything about a squared, b squared, and c squared. So let's go ahead and take the square root of all of these so we can actually use these for a graph. All right, so square root of 16 is 4. Square root of 9 is 3. Square root of 7, and that's going to be approximately 2 point something. If you type that in your calculator, you don't put it underneath. Type it in your calculator. It's approximately 2.65. I'm going to go with 2.7. All right, we actually have all the information we need to graph this thing, so let's do it. All right, here we go. We're graphing number 1. Center is at 0, 0. The A value is 4, and that is along the x-axis. So I'm going to count 1, 2, 3, 4. And 1, 2, 3. I'm over at -4. The B value is 3, so I'm going to go up 1, 2, 3. And down 1, 2, 3. I'm going to go ahead and sketch my wide or horizontal ellipse. Kind of close to a circle because this is 4 and this is 3, so it's not too much off. All right, C is 2.7. That goes on the major axis. So that's 1, 2, 2.7. I'm like close to 3 here and close to -3. And those are my foci. All right, I do want you to name out these points for me. So let's go ahead and name those. So my vertices, we'll go over and look at our graph. My vertices, it appears, are located at 4 and -4, 0. My co-vertices, it appears, are located at ±3, no, excuse me, 0, ±3. And my foci, which follow along on my horizontal axis, since this is a wide one, are located at positive or negative radical 7, 0. I would like you to leave this in exact form with the radical rather than put the decimal here. The only reason I got the decimal of 2.7 is I wanted to know where to put the dots on my picture. All right, so not too bad. These ellipses aren't awful. Let's go ahead and move on to example 2, our last example together. All right, for example 2, again, I have the equations at the top for you, so whether it's a horizontal or a vertical, you can get them from your chart. This time they want us to write an equation of an ellipse that passes through ±2, 0, and it has foci at 0, ±5. All right, just like with parabolas, I think a sketch is really helpful for an ellipse. So let me just do a quick sketch over here. It passes through 2 and -2, so I'll put dots there. Foci at 5 and -5. Remember, those foci are always on the major axis. Now, I don't know where the vertices are yet, but I know they're going to be somewhere above the foci, so I'm just going to sketch it in like this. And I want to make a note that I have a tall ellipse or a vertical ellipse. So I'm dealing with this equation. That's going to definitely help me later. Now, I told you before that the distance from the center to the foci is considered C. So that means that C is 5 here, the distance from 0 to 5 or 0 to -5. Now let's see. If this is the foci, what are these points over here? Are these vertices or co-vertices? Well, the foci always go with the vertices, which means these are my co-vertices. So my co-vertices must be out here at positive or -2, 0. So co-vertice distance from center to co-vertice is B. So that means B is 2. So I have C, I have B. I don't have A, but I'm going to use my equation. A squared minus B squared equals C squared. Let's go ahead and square these so we have something to work with. So B squared is 4, C squared is 5 squared, or 25. I'm looking for A, and then I'll be looking for A squared right after. All right, so A squared minus B squared, in other words, A squared minus 4, equals C squared, 25. Let's add 4 to both sides. A squared is 29. All right, so we'll put A squared is 29, which means A is the square root of 29. So a little bit bigger than 5 if I were drawing this. I think it'll be like 5.4-ish. I have my sketch over here. It's not critical because I'm not graphing it out exactly, but if I was, I'd want to go to a 5.4. All right, we are just about ready to write this equation. So we know that we're going to need our A squared and our B squared. We know that it's going to be in this form, so let's just fill it in. So we have x squared over the b squared, which is 4, plus y squared over a squared, which is 29, equals 1. Mission accomplished. Before we go into comprehension check questions, I just want to point out one more thing about example 2. We said that the major axis was equal to 2a and the minor axis was equal to 2b. All right, so how long is that in this case? So my major axis in this case would be equal to 2 times radical 29. So my major axis is a length of 2 radical 29. My minor axis would be equal to 2 times b, which is 2 times 2. My minor axis is 4 units long. It's a little bit easier to see that this minor axis is 4 units long. It's kind of hard for me to imagine that this is 2 radical 29, but it does make sense. If this is the square root of 29 plus another square root of 29, that whole distance would be 2 radical 29. All right, let me give you your comprehension check questions. All right, there is only 3 comprehension check questions this time. For the first 2, I'd like you to state both the center and the foci of each ellipse. And these are the 2 equations for number 1 and number 2. X squared over 32 plus y squared over 48 equals 1. That one's in a friendly form. Hopefully you spot right away that a squared is the larger number. Look which variable it's hanging out with. It'll tell you what your ellipse is going to look like. Your second equation does not equal 1. So how are you going to get it not to equal 1? Right now it equals 100. Maybe divide each term by 100 and then go from there. All right, those are your first 2 questions. You only have 1 more to do. Let me give you the third one. And comprehension check question number 3. Write the standard form equation of the ellipse with vertices at plus or minus square root 15, comma 0, and foci at plus or minus 2, comma 0. All right, great job today on ellipses. You have 1 more task. In your notes, please write down just 1 more word for me. When you think of the Lord, write down a word that starts with M that comes to mind. Please make sure I can find this word in your notes. I'm guessing it'll be right at the very end, so it'll be easy to spot. Then you're going to send in your notes picture. I will respond with the answers to your 3 comprehension check questions. And if they are incorrect, I'm going to ask that you fix number 1, number 2, and or number 3, and then just resubmit your notes to get full credit. All right, I will talk to you soon. Have a great night.